Algebra Unit 4, Lesson 4, Notes 4, Understanding Compound Inequalities. Truth values. When considered together, two inequalities such as h is greater than or equal to 52 and h is less than or equal to 72 form a compound inequality. A compound inequality containing and is only true if both inequalities are true. Otherwise, it's false. So determine whether each statement is true or false. So look at each piece individually. Again, both pieces must be true in order for the inequality, in order for the truth value to be true. So, letter A, I am in math class. True. And I am in 8th grade. True. Because those are both true, your truth value is true. Let's do one more. Letter B. I am in math class. That is true. And I am in science class. Well, if you're in math class, you can't possibly be in science class, so that's false. Because they are not both true, your truth value for this is false. Try the next two. Another type of compound inequality contains the word or. A compound inequality containing or is true if at least one of the inequalities is true. The only time it is false is if both are false. So let's mix it up. Let's do G this time. I am in science class. That's false. I am in 7th grade. Also false. Therefore, you are either in science class or in 7th grade. Since both of them are false, the truth value of this is also false. Only one needs to be true. Letter H, I am in 6th grade. False. I am in algebra. True. So read it all together. I am in 6th grade or I am in algebra. Because one of those is true, the truth value is true. Let's try it with some math. We're going to treat these the same way, except for they're either math inequalities or equations. Determine whether the following mathematical statements are true or false. So look at each piece individually. 3 plus 5 equals 8. Well, yes, 3 plus 5 does equal 8. That's true. 5 is less than 7 minus 1. Well, 7 minus 1 is 6. Is 5 less than 6? Yes. Now we need to focus on the word and. 3 plus 5 equals 8, and 5 is less than 7 minus 1. Because those are both true, this is also altogether true. Letter J. 32 divided by 4 is greater than 11. Well, 32 divided by 4 is 8. Is 8 greater than 11? No, it's not. That's false. 7 is less than or equal to 2 plus 1. 2 plus 1 is 3. So is 7 less than or equal to 3? That is also false. So 32 divided by 4 is greater than 11, or 7 is less than or equal to 2 plus 1. Since those are false, this is also false. Letter K. 9 minus 7 is less than or equal to 2. 9 minus 7 is 2. Is 2 less than or equal to 2? Yes, that's true. 7 times 6 equals 48. 7 times 6 is 42. 42 equals 48 is a false statement. And we have the word or. So either 9 minus 7 is less than or equal to 2, or 7 times 6 equals 48. Since one of them is true, this is also true. Letter L. 10 plus 2 does not equal 12. Well, 10 plus 2 is 12. So 12 does not equal 12 is a false statement. 8 minus 3 is greater than 0. 8 minus 3 is 5. 5 greater than 0 is a true statement. However, this is an and. situation. So we have false and true. Something can't be false and true at the same time. Therefore, this is also false. Interval notation. A notation for representing an interval as a pair of numbers is called interval notation. The numbers are the endpoints of the interval. Parentheses and/or brackets are used to show whether the endpoints are excluded or included. For example, -8 and -5. We've got a parenthesis and a bracket. It's the interval of real numbers between -8 and -5, excluding -8 because of that parenthesis, and including -5 because of the bracket. And the graph is shown below. So we have an open circle on -8, so open circles mean parentheses, and we have a closed circle on -5, which means a bracket. So write the solution to each graph in interval notation. Okay, so we have -1 and 2 where the circles are. For letter A, I'm looking. So I'm going to start by writing -1, comma 2. -1 has an open circle, so parenthesis. And 2 also has an open circle, so another parenthesis. And that's it. Letter B. We have 4 with a circle and 7 with a circle. 4 has an open circle, therefore a parenthesis. 7 is a closed circle, therefore a bracket. So again, parentheses mean exclude, brackets mean include. Try C and D. Compound inequalities aren't always between two numbers. They can also go in opposite directions. For example, this right here is the interval of real numbers less than or equal to 3 or greater than or equal to -6 as shown in the graph below. 3 and 6 are both included values, so they have brackets. Infinity, which is this symbol right here, looks like a sideways 8. It never has a bracket because it's not a finite number. However, it needs to be distinguished by a negative or a positive depending on the direction of the arrow. So right here we have -infinity to 3 or 6 to positive infinity. So that tells me that 3 is a bracket, it's a closed circle, and it goes all the way to -infinity. Infinity can never have brackets, it's always a parenthesis. Over here we have 6, which is a closed circle, therefore having a bracket, all the way to positive infinity and having a parenthesis. Letter B. I have arrows going in opposite directions, so I know this is an or statement. And I have 4, which is included, and -infinity, because it goes on forever in the negative direction, and infinity has to be in a parenthesis. Over here we have 7, which is not included, therefore a parenthesis, comma, and it goes forever in the positive direction, so it would be positive infinity, also with a parenthesis. Letter C. Again, we're going off into -infinity, so -infinity, and bringing it to -6 is my first circle. It is open. I have to put that word or in there. -2 is included, so a bracket at -2, comma, and it goes on forever in the positive direction, so positive infinity with a parenthesis. Finish A and D.